Hello Internet, my name is Quinn and this is Blondihacks. I'm working on the Locomotive this week and I'm going to finish the expansion links and we're going to see how they fit into the Locomotive. The expansion links, as you recall, are really the secret sauce of wall shirts, and it's going to be really exciting to have these extremely complicated assemblies finished and working, so let's go. When last we left this assembly, we were almost done with the trunnion plates. I'm going to assume you've watched the previous video in this series so you know what's going on here and how we got to this point. The next step then is to drill the holes through the center of the plates, and this is where the trunnion pins attach. Because the expansion link is a sandwich of 3 components, and the middle layer has the expansion block sliding up and down in the middle, we can't put a pin all the way through it in order to mount it to the Locomotive. So there's 2 pins, one on either side, that attach to these outer trunnion plates. These holes get drilled and reamed because we're going to be making the pins to go in these holes, and they're going to get silver soldered in place, so we need a really accurate fit for these pins. Things are about to get weird though, because I need to cut them free now of the stock that they're still attached to for fixturing. However, as soon as I do that, they're no longer attached to anything, and there's potential for the part to go flying and get mangled by the cutter and so on. So I'm going to add a strap clamp to the middle of the part so that as I cut the part free, it's not going to go anywhere. The easiest way I could think of to do that was just to drill and tap a new hole in my fixture block to hold a strap clamp. The great thing about a sacrificial fixturing surface like this is you can just do stuff like this anytime you need to on the fly. I didn't really plan ahead for this part of the operation. I wasn't sure how I was going to free the parts from their base material, but once I got here, the answer was obvious and simple because I don't have to worry about drilling holes in the fixture. These end cuts are actually really neat because the ends of the plates are square to the arc of the curve of the trunnion plate. So that means I can make them in this same setup on the rotary table by simply swinging the table around and cutting on the y-axis of the mill, just like we did so many other features on these parts. To determine this exact angle, I once again went to the CAD drawing that I showed you in the previous video in this series to figure out what the angles were going to be, of course accounting for the radius of the cutter that I'm using. On the final cut through the material, nothing seemed to move, so that was good. Of course, that's just one end. The other end is still attached to the base material, but if my clamping was insufficient, we'd probably have seen some movement at this point because it's only held in by a very thin bit of material on the far end. This is the real acid test though, the exact same cut on the other side of center. Again, final cut, nothing seemed to move, so maybe success. Here's the moment of truth, let's find out. Hey, look at that! It's a trunnion plate, wrenched free from the bonds of the steel from which it was trapped. That is pretty neat, I gotta say. On the outer trunnion plates, things got a little more interesting. You can see there's some copper packing underneath the part, and that's because there's a valuable lesson in here in fixturing. You recall I added those dowel pins on the end so that the fixture would repeat from part to part and I could cycle things through. And that's fine, it doesn't matter actually where those dowel pins are, as long as every part always maintains the same orientation relative to those pins. However, in this case, I needed to occasionally flip one of the parts over on the fixture. And for that to work, the fixturing pins have to be symmetrical to the features of the part on the axis that you want to flip that part. And in this case, they are not. I did not take any care to center the pins perfectly on the x-axis of the parts. So when I flip them over, they shift a little bit on x. To get around that, I had a couple of operations like this one that really needed to be done with this side of the part up. So I had to resort to packing underneath because I couldn't flip the parts over and clamp them down that way. You know, it's a subtlety about fixturing, but it's a good lesson that it never hurts to make your fixturing pins perfectly centered on the parts on every axis, just in case, even if you think you won't need it. Fortunately for me, not a big deal in this case. I was able to work around it, and the outer trunnion plates came out of there very nicely as well. Alright, so far so good. The trunnion plates came out nice and they seem to line up very well. I did a quick sanity check with a gauge pin through the holes to make sure that the 2 sides of everything are going to line up. Of course, in the final expansion link assembly, these pins need to be exactly opposite each other so that the expansion links can rotate freely. That seems like that's all going to be okay. With the trunnion plates essentially done, now I can go back and finish up the expansion links. They are still buried in their host material because I still need to cut the little dogleg features at the bottoms of these plates. For this, I'm going to lay that out. The shape of it is really just cosmetic. As long as that hole that was drilled on the DRO is in the correct position relative to the slot, then the mechanism will function. So once again, I turned up a little pin on the lathe, which I will use to trace the outline of the rounded end of that. This method worked really well on the previous features like this, so I did it again here. And then the trunnion plates themselves define where the bottom of this dogleg starts. And so that's why we had to pause on the expansion links and go to the trunnion plates next. So I can mark the end of the trunnion plate and then connect the dots to figure out where the sides of the little dogleg land. The top edge is connected to the end of that top surface, which, as you may recall from the previous video, forms a fillet to create the inside elbow of the little dogleg. I did the top cuts of the expansion links first because that was identical to the trunnions. Of course, you can see that the two plates are still super glued together all this time, so I'm cutting the top edge of both expansion links at the same time, but now I can go down to the tricky cuts at the bottom where the dogleg is. I went back to my CAD model of this part to figure out what the angles of these cuts actually need to be, so I could set those angles on the rotary table. Again, I can take advantage of my setup for the angles, but for the X position of the cut, that's where I used my layout line. Similar to how I did those tricky angles on the insides of the trunnion plates, the angle I got from CAD, but the X position I got just by sneaking up on my layout line with magnification. The top cut was fairly easy. I could do that in this exact same setup. And then I got to swing the cut around to a different angle for the lower edge of the dogleg. And this one I do need to add an additional clamp. Luckily, I was able to sneak a toolmaker's clamp in and just grab the bottom edge of that dogleg, because similar to the trunnion plates, once I finish this cut on the dogleg, there's going to be nothing holding that part into the base stock. And I had to remove my fixturing screw on this end because it was going to be in the way of this cut. So hopefully this little toolmaker's clamp solves both those problems. It holds this end of the material in place for the cut, and as I free the expansion link on the final pass, it's going to keep it from flying off and hitting the cutter and potentially getting scrapped. Space got very tight in here though. At the end of each of these passes, the spindle on the mill was thousandths of an inch from the clamps, so I was really looking around from every angle as I moved it to make sure I'm not going to hit anything. This is what you might call the clearance dance. You know you've done it. Once again, nothing seemed to move as the cutter broke through, so cautiously optimistic that I might have an expansion link when I'm done removing this clamp. Let's find out. It's looking pretty good. Yeah. Look at that. That is most of an expansion link. Some finishing yet to do, but it's been a real long road to get to that point. It's nice to see this part in the flesh. So first of all, I'll get rid of that big ugly point on the end where those two angle cuts meet with the fret saw. And then conveniently, that little button that I turned on the lathe to trace the outline of this on the layout is also a pretty handy filing button. It's not hardened and I only have one, but it only has to survive for a single filing operation, so that's just fine. It did save me a lot of effort trying to file to those layout lines. I did have to take extra caution to hold the file square to the work, really pay attention to my filing marks while doing this because I only have a button on one side, so it would be pretty easy to get crooked with the file. But that seemed to go well. And then I did also have to do a little bit of additional needle filing where the two cuts meet from the angle of the dogleg and the top radius of the part in that little fillet area, the elbow as I called it before. It was pretty much impossible for me to get those cuts to meet perfectly right off the tool because I couldn't really see what I was doing. It was on the back around the side of the rotary table, and so I was really kind of going a little bit on instinct in there. It's finally time to separate these expansion links, and my usual go-to for this is to soak the whole assembly in acetone, which removes layout dye and softens the super glue. normally. Sometimes I got to soak it for a couple of minutes to make this work. The acetone will wick its way in there and eat the super glue. However, this time, somehow no amount of soaking worked. I soaked it for a good 20 minutes and still these parts were extremely stuck together. I tried a little percussive persuasion as well, but this was hard to do without risking damaging the parts, so I couldn't get too crazy with that. Heat always works for breaking super glue, but I was trying to avoid that because it also discolors the part and creates a bunch of extra cleanup work. But I really had no choice at this point. I had to resort to the torch, and I just tried to use as little heat as possible. I went very carefully, a little bit at a time, to try and just heat them up enough to break the glue. I know a lot of people have a hot plate in their shop for this kind of thing, and I think that's probably a good idea. I do have a toaster oven, but that just takes too long to heat up. Some very careful and surgical heat application, however, did result in success. I've never seen two parts stuck together this well before. I think because of all of the machining that was done on them all the way around at funny angles and stuff, I think the burrs between the two layers had really locked them together, so the acetone just couldn't get into the glue, and everything was also mechanically held for that reason. But some heat wins the day. Next pieces to make are the trunnion pins that go in the outsides of the whole assembly. For this, I grabbed this piece of 1/8" round bar. This is like that really crappy steel that you buy in big box stores from those racks. It's really terrible stuff. It doesn't machine very well. However, it was the perfect starting diameter for these parts, so I thought, well, I'll try and make it work. I do kind of want to use this stuff up. These pins are a shouldered pin. There's kind of a belt line shoulder around the middle of it, and then it's a smaller diameter on either side. So I started by turning down to the overall belt line diameter, then I turned the pin down on one end. Next I come in with a very small grooving tool, and I do an undercut right underneath that shoulder. And what this does is gets rid of the tiny little fillet that's left by the nose radius on the turning tool, and will ensure that this pin sits square on the face of the trunnion plate. If it didn't, then the dimensions would be wrong on the whole assembly, because of course the distance across the outer edges of the pins has to be correct. And it won't be if the pins are sitting proud of the surface because of that little fillet. Then the diameter on the back side of the shoulder I cut with a grooving tool so that I can do it all in the same setup. Now we're almost done with this order of operations, but pay particular attention to the final step on this that's coming up in a minute, because the final step is really what makes or breaks these parts. It's really critical, so you're going to want to stay tuned for that. Unfortunately, I don't have any kind of micrometer that's thin enough to get in on that little shoulder and measure my progress, so I'm having to use the guessometers, but in a situation like this, I tend to just err on the side of a little bit high, and then you can always do a little bit of sanding or filing at the end if you need to. But because it's an inside shoulder cut, I can't test fit it on the part to know when I'm right there. Now I'm going to use the grooving tool to part these off because it's already set up and I've already located its position on the DRO and so on. There's no need to switch out to a parting blade at this point because they're small parts, so grooving tool works just fine. Now, Yahtzee and all that, but we're not done. The final and most important operation is still yet to come, so hang on one bit longer. To clean up the ends and do some other finishing work, a drill chuck actually makes a really nice little hand vise for these tiny round parts. Parts this small and round to boot can be very difficult to hang on to. Drill chuck to the rescue. I did a little bit of fitting and fettling until these were a perfect fit, both flush with the back and diameter-wise in those holes. That looks really good. Now for that crucial final step that I talked about, this part goes straight in the trash because it's garbage. You can't really tell on camera, but the surface finish on this top part is really, really awful. That's the first one I made. The bottom four were made with a high quality piece of 1144 steel that machines beautifully that I found in my bin after looking a little harder. That first one that I tried to make work from the cheap steel, it just really wasn't going to be sufficient because these are bearing pins, so they need to have a nice smooth finish on them. And luckily my urge to make quality parts outweighed my urge to reuse old material. Somehow those big box store steel racks managed to make even 1018 steel even worse for any kind of serious machine work. We have all of the bits now, so we can do a little bit of mock-up and get our first look at what the final assembly might look like. The pins go in the trunnion plates, and then the whole assembly gets sandwiched together and held together with some screws. And that is looking pretty good. So we can move on now to the silver soldering, so we can attach those pins permanently into the trunnion plates. Here's my setup for that. The weird wedge of broken jewelry maker's fixture plate is holding the pin upwards into the underside of the plate. I wanted to silver solder them from the back so that I get a nice fillet around the pins. However, that does mean that the pins are at risk of falling out during this operation. The pins are a close push fit into the holes, and they stay in there on their own, but when everything gets heated up, if by chance the trunnion plates expand a little more than the pins do, the pins could fall out, or even worse, they might shift a little, which is quite difficult to fix. This janky setup, however, seemed to work just fine, so once I had success on that first one, I cycled quickly through the other 3. Everything here, of course, has been pickled and fluxed, and I prepared all 4 assemblies for soldering ahead of time so that I could cycle through them quickly on the torch. All 4 of those then went back in the pickling acid for cleanup. And while they are pickling, I need to shorten 4 screws for the assemblies to get bolted together. I'm using brass screws here temporarily because I don't have steel ones in the right size, but these will be steel when the job is done. They, of course, come out of the pickling acid a frightful mess, but that's okay. A little bit of elbow grease, and those will clean up very nicely. Here are all of the major components. Looking pretty good. I filed the silver solder flat on the back to make sure there's clearance for the radius arms to move in there, and the fillets came out nice. Now, one detail missing. You remember how the link blocks slide in these curves. However, of course, they can't reach to the ends of the slots yet because of the radii left by the end mill. So it's needle filing time to correct that situation. When I first got into model engineering, I really dreaded this kind of work. But honestly, now I kind of enjoy it. Like, the more you do it, the better you get at it, and it's really kind of a zen and satisfying experience. You're really getting your hands on the work, and you really feel like you're making it nice, if that makes sense. And it's very satisfying when you get a hand-filed square slot like that works really well. Here's another look at how those link blocks move, because I think it's really neat. This motion isn't going to be visible in the final assembly because it's all trapped inside the expansion link, but while it's apart, we can enjoy it. Then with the assemblies assembled, I guess, I did a little bit of Scotch-Brite wheel work on the outsides of them. Because I did those radius cuts in a lot of light passes, you get a lot of tool marks. And I don't regret doing it that way because it ensured that I didn't stress the fixture, and I got nice cuts, and I didn't have trouble managing chips and so on. But the price I paid for that was lots of tool marks. So some Scotch-Brite wheel kind of blends all that together, cleans everything up nicely. And let's do a little test fit on the radius arm, make sure my clearances are all good there. And that looks really good. That moves in there nice and freely, so I think we are in good shape on these. You can also see now how the angle cuts that we did on the backs of the trunnion plates give clearance for the radius rod as the expansion link rocks back and forth. Hopefully that all makes some sense now. But more importantly, let's get these on the locomotive and see how they look in situ. Of course, I can't mount them because the link brackets that attach them to the frame of the locomotive aren't made yet. They just have to kind of hang in space, but I'll hold them up here so you can see kind of what they're going to look like. One of the interesting things about machining is that it's very much a cognitive journey, I think, for all of us. You learn what your own strengths and weaknesses are in the way you work and the way you think. When you're doing something like this where mistakes have such a high cost, you really learn what your own sources of error are. And I was personally amazed that I made parts this complex without a single significant error. This was 10 days of work, all difficult operations, and basically not a single error. And I think that's why I didn't make a single error, because the parts are so complex and difficult. I think I have this weird cognitive thing where if a part is really easy, I don't make mistakes because it's literally easy. I can make 100 bushings and not make a mistake. And then a really hard part like this, I don't make mistakes because I'm really focused on what I'm doing. I'm really thinking everything through. I'm triple checking everything. But then in the middle, there's this zone of medium difficulty parts like the combination levers and the radius arms, where I'm overconfident and I think I've got this. I don't have to think this through very far. And that's when I make all my mistakes. So I'm trying to now treat every part like an expansion link and hopefully reduce my mistakes in the machine shop. This little cognitive journey is going to be different for all of us. We all have different ways of thinking and different things that we're good and not so good at in the machine shop, and I'd be curious to hear what your journey is like. But I hope you've enjoyed watching me make these parts. Thanks so much for watching. Thanks to my patrons for making this all happen, and I'll see you next time.